Could any 3 points give me a triangle? Well, no. They had to be non-collinear. Now, joining these 3 non-collinear points, I get 3 sides. Now, the next question was, could these 3 sides be of any length? No again. The sum of 2 had to be greater than the third. Now, with these 3 sides, I get 3 angles also. That's why triangle. So, these 3 angles. Now, again, the obvious question. Could these 3 angles be of any measure? Well, yes, the obvious answer too, no. The sum of angles is equal to 180 degree. Now, let's try to see how it is 180 degrees. So, let's take this triangle and say these angles are A, B and C. I want to find the sum of these angles, these 3 angles. Let me fold this triangle. Let me fold it like this. So what do you see now? Now A, B and C, all these 3 angles are on a same straight line. And we know that on a straight line, the sum of angles is 180 degree. So since they are on the straight line, A plus B plus C would be 180 degree. That is what we had to find. A plus B plus C. Another way is, let's tear these angles. I want to find this. A plus I want to find B also. Let me tear B out. And I want to find C. So let me tear C also. So I have this A, I have this angle B, and I have C. Now let me try and arrange this. So you can see that if I arrange these 3, then again A plus B plus C all come on a straight line, and hence sum of angles on a straight line is 180 degree. Therefore this is 180 degrees. A plus B plus C is 180 degrees. Well, this is no magic. Let's try to see this mathematically. So this is a triangle, and say we want to find these angles. I call this as angle 1. I call this as 2, and I call this as 3. So what I want to find is 1 plus 2 plus 3. So for this, what you need to do is draw 2 lines. So I produced this line further, and from the opposite vertex, what I do is I just draw a parallel line to this. So I have these 2 parallel lines. These lines are parallel. So let me represent it by this sign. So I have these 2 parallel lines. What I want to find is 1 plus 2 plus 3. Now let's look at this. We know that if 2 lines are parallel, interior alternate angles are equal. And how can I find interior alternate angles? If I can find out a Z, the letter Z or an inverted Z. So let's see. You can find Z here. I can find an inverted Z here also. So I can say, since this is a Z, angle 3 and this angle should be equal. So I'll name this also angle 3, because both should be equal, interior alternate angles. Again here, 2 parallel lines, I can spot an inverted Z. So angle 1 should be equal to this angle here. Let's call this also angle 1. So what I see is 1 plus 2 plus 3 all are on a straight line. So angle 1 plus angle 2 plus angle 3 should be equal to 180 degrees. So 1 plus 2 plus 3 is equal to 180 degrees. So now can you tell me what x would be here? So what do we know? Sum of angles in a triangle should be 180 degrees, and x is one of the angles. So I can say that x plus 50 degrees plus 60 degrees should be equal to 180 degrees, because sum of angles in a triangle is 180 degrees. Now x, so I can write it as x plus 50 plus 60 is 110 degrees. This should be equal to 180 degrees. So x is 180 degrees minus 110 degrees. This is equals to 70 degrees. So I find x is equal to 70 degrees. So this x would be equal to 70 degrees. So now I know that in a triangle A plus B plus C, that is sum of the angles, is 180 degrees. What if I make one of these angles greater than 90? Let's say, let it be 91 degrees only. So what I do is, angle A plus angle B, instead of C, let's make C greater than 90. For say, let's say it would be 91 degrees. So if one angle is 91 degrees, what would be the sum of the other two? That would be 180 minus 91. 180 degrees minus 91 degrees, which would be 89 degrees. So if one angle is greater than 90, the sum of the other two is less than 90. So that means neither of these two angles can be greater than 90. So only one angle in a triangle can be greater than 90 degree. So now let's try to see whether C can be 90 degrees or not. Now let's see what if one angle is 90 degrees. So we know A plus B plus C is 180 degrees. Let's make C 90 degrees now. So angle A plus angle B plus, instead of angle C, I'll write 90 degrees, is 180 degrees. So I know angle A plus angle B would be 180 degrees minus 90 degrees, which would give me 90 degrees again. So sum of two angles is 90. One of them cannot be 90 because that means the other would be 0. That means we just left with two angles. And hence it's not a triangle. We need three angles for a triangle. So what I observe is that if sum of three angles is 180 degrees, only one angle can be equal to or greater than 90 degrees. So if one angle in a triangle is greater than 90 degrees, that is an obtuse angle, then we say that the triangle is obtuse angle triangle. If one of the angles is 90 degrees, then I say that it's a right angle triangle. 90 degrees or a right angle. 90 degrees is equal to right angle, is a right angle. So I can say that this triangle would be a right angle triangle. In fact, to signify a right angle triangle, I just draw a small square here. This looks like I complete a small square on the vertex where the angle is 90 degree. So if B is the vertex, angle B is 90 degree, all I'll do is I'll complete a square here, or you can say I'll draw two perpendicular lines. This means that this is a 90 degree angle. And the side opposite to this 90 degree, the side opposite to this 90 degree angle is called the hypotenuse, which is the longest side in this triangle. And if all three angles are acute, then it's an acute angle triangle. So what we basically learned from this lecture is that sum of angles in a triangle should be 180 degrees. Further, if I classify a triangle according to the angles, then if one angle is obtuse, obtuse angle. If one angle is right, right angle triangle. And if all three are acute, then it's an acute angle triangle.